I was talking to her, I forgot. I just was so tired. I didn't feel like saying Uncle Lobo, so I called her an
So me.
I was like, you're a solid dude.
I'd be like, what the heck is an oop?
I was really lazy, so I didn't feel like saying Uncle Lobo.
I know, you've already said
3 more syllables.
It could be an oop and a drop.
This is, I don't know.
Or a happy an apple. An apple with a bite out of it.
Dude, I was trying to make a
Why?
reservation, because apparently when you get your iPhone fixed, you have to like make a scheduled reservation. That thing was bad, but I was making one, I like stood on the phone, I was like, can I have
The phone?
I just like,
It's a phone.
We started again.
It's not plural. When you talk on a phone, you don't talk on a phone.
No, I talk on phones. I had two in my ear, so. Yeah.
Well, you also say mines.
Actually, I
so.
don't say that anymore. I say mine. And I say Red Robin now, too.
I'm so proud.
What?
I never thought this
What is
Okay,
this?
when people
I
say
think
like, I'm
it's-
going to Myers, I'm like, it's Meyer. You don't plural.
It's like, you don't say, I'm going to Walmart.
I'm going to Walmart. I'm going to Targets.
I do.
Well, you're
I'm gonna go to
buy
Target because
milks.
I'm being sarcastic. I'm gonna go to
I'm
Target.
gonna buy milk.
It's hard to tell. You say other
I went
things.
to Kroger with my little brother and his
Kroger's?
friend. Yeah, I went to Kroger. But the thing is, my brother kept calling me mom.
Scott's.
And so then I was like the weirdest place because I'm like this little person with like my brother and like his friend who are both taller than me. And she was
I told him, I was
just like, I'm not your mom.
I told them that
I
my
went to
dad's
the
name
store
was
once
like, you know,
with
Matthew
the
needs to go by
ladies
Matt. My dad's name
She
is
went back
Scott
into
Few,
the
and they're
store, standing there
like,
and
really?
And I was holding her.
No,
and I was like,
That doesn't make
sense.
she's not mine. She's not my child. Look at she's the baby's.
Jordan, you have lots of pet peeves for some reason. 17.
Hey,
You emphasize stuff like pet peeves.
well, don't worry, I do.
I just think that in general, human rights is
You guys
very
live like
irritating.
you're like 7 years old and you've like gone through like almost your entire life cycle.
You call us dead.
I mean, we're all dying, but. I
You
told
said
my
we went through most of our life.
No, she said she acts like she's gone through like majority of her life cycle. She goes, back in my day, people used to say mines.
I don't even say back in my day.
I know, but you.
Back in my day.
It is your day. It doesn't make sense.
I'm still in my day.
Yeah.
Hey, how you guys?
Hey, that's where my
I'm
phone is.
actually on the radio. Yeah,
Hey,
Hey, McDonald's. I work to register at McDonald's.
I was working at
You should, because this lady, oh my gosh. She took her 5 minutes to figure out, to give me 53 cents. And so,
The register at Plant Center is so complicated.
I have to ask the two guys.
Alright. So, yeah, left this semester, it's probably redundant at this point, but this week, next week, finals week, that's it. The plan will be on either Friday of next week or Monday of finals week to have a
We do Friday.
quiz test like object, whatever it would be, 100 to 120 point thing. Friday, you guys, yeah, everybody's on board, or at least 2 out of 4, that's a pretty strong number to be vocal about.
Friday.
So,
Friday.
yeah, we'll plan on Friday. At this point, I think we have 3 or 4 sections down, and then by that point, we'll have however many more. That'll be a nice way to get the last chunk of material digested on our way to the final. The final is going to cover the second semester. Not everything. Some things were visited only once and never revisited. Other things we saw multiple expressions of, so
All the sine, cosine graphs.
you can guarantee those are going to be on there with how much was on
That's
them.
all.
Right?
It's only visible, it's no problem.
There were 3 sections on that, so you can bet that's going to be on the final. And I don't know when I did this, but I think at the beginning I went over some of the basic things that are covered in like every pre-calc class, and one of them is sine and cosine graphs. So it's just so important because there are things in nature that are periodic. The Earth going around the sun, the little mass balancing on a spring, whatever it may be, there are things, a pendulum going back and forth, tick-tock, like your grandfather clock, that you can graph out. Say what?
Sorry, that rhymed.
You can graph that on a sine wave. So as the clock goes back and forth, it's going from one position to the next. And if you graph the position of the clock thing that's hanging down, whatever that's called, if you graph its horizontal position over time, it would be a sine wave. So because these things are so prevalent in nature, and because if anyone ever takes a class in anything relating to engineering, you're going to see those things all the time. So nobody in here may end up doing that, but I have to prepare you for that. I'd be disserving you guys as students of possibly anything at this point, right? Because you're potentially going to become a student studying anything in college. I have to go over that stuff. But for now, actually relating roughly is law of cosines. So this is our next thing. Now, let's recall for a minute what the law of sines was, because that's going to be related. The advantage to law of sines was we can look at triangles that are not right triangles. And if we look at the angles as angles A, B, and C, and the sides opposite as the lowercase versions of the angles, then we can say that sine A over A equals sine B over B equals sine C over C. And the beauty of this is that we're using sines in triangles that are not right. Now, you can drop in a perpendicular and start playing with that, and that's where you come up with the expression for the law of sines. But the point is, even though you don't have right angles, you can still talk about sine, which relates to right triangles. That's neat. Not right triangle, using sine. You can use it with this expression. Now, let's, we'll be good. Let's go about trying to prove the law of cosines, or at least a form of the law of cosines, and then we'll come up with multiple forms. So, to start, let's start with a triangle. Angles A, B, and C, and side lengths of A, C, and B. Now, here's what we're going to do. We're going to start by dropping down a perpendicular. And the perpendicular is going to have a length of h. We'll call that h for the height. And where that perpendicular drops down is not clear. So what we'll do is we'll say, okay, this little measure on the left we're going to call x. That's some of the length of b. But the other bit of the length of b is going to be that guy to the right. Now think about this for a second. If the whole side has a length of b, and the one piece over here has a length of x, what's the length of the piece that's not labeled? B minus x, good. It's the whole thing, take away the piece that's already accounted for. Right, that makes sense? Now, I'm going to have my book open to make sure I don't make a mistake here, because this is one that's a little bit more demanding. Okay, so we can say this. The cosine of angle A, we're going to talk in terms of cosines now to do the law of cosines. The cosine of angle A is x over c. Agreed? Good. Okay, so at this point we can say x is just c times the cosine of A. Multiply both sides by c. Are you guys okay with that? You could cross multiply and get the same result. Okay, now two other facts that we know. One, we know, well, we may know more than two facts, but two other things that we know for sure. X squared plus h squared equals c squared. Are you guys okay with that? Bless you. two legs of a triangle equaling the third, the hypotenuse, x squared plus h squared equals c squared. And the other one is going to be h squared plus b minus x squared equals a squared. You guys agree with both of those? I'm going to FOIL this out for a second because b minus x times itself will simplify down to b squared minus bx plus x squared. And at this point, I'm going to take what we have written here as, well, notice this is one big addition problem on the left. What if I take the h squared plus the x squared and group that together first? And then we'll do the b squared minus 2bx. Why 2bx is because, well, minus bx is taking the 2bx's. Are you okay with that adjustment, algebra? Put these two things to the left and those things to the right. But look at this. This is just c squared. H squared plus x squared is the same as x squared plus h squared. This is c squared. And what about the x here? If I want to get things strictly in terms of a's, b's, and c's, because that x was a superficial value that we threw in just because we needed something to express that length, and the other length is b minus x, we can plug in for x as c cosine a. And we get c squared plus b squared minus 2b, plug in for x, c cosine a equals a squared. And that is the first form of the law of cosines. So when we talk about the law of cosines, these ones are nastier to remember, but useful when law of sines is not going to work. A squared equals b squared plus c squared minus 2bc cosine a. It's true. We used all equalities that we know to be true. We used Pythagoras, and cosine. And we just kept plugging in, and we came up with the big expression. Now, the fact that we went down to side B and broke side B into two pieces is no matter. We could have broke any of the sides into any of pieces. So just as easily as you could have a squared, b squared, and c squared, you could also have b squared equals a squared plus c squared minus 2ac cosine b. And you could have c squared equals a squared plus b squared minus 2ab cosine c. What I want you to do, though, as you look at these forms, is to notice that all three forms are really the same. It's just A, B, and C playing different roles. So in the a squared case, you have the b and the c squared on the other side, minus 2bc cosine a. In the b squared case, you have a squared and c squared on one side, minus 2ac cosine b. In the c squared case, you have a and b squared on the other side, minus 2ab cosine c. So there's a consistency in the forms, although they're each on their own. I guess even starting from memorizing first, that's going to be a chore. But once you get one down, you can have them all just by replacing, or rather interchanging the roles of A, B, and C. You guys okay with that? So it makes sense. There's three algebraic equations that are simple to see. It can be written in three different forms based on the roles of A, B, and C, and you'll see here in this first example why law of cosines would ever be used. Solve the triangle. We have 36 degrees for the angle off to the left, y for the measure up on the top, and m for the angle to the right. 7, 10, and x for the side lengths. I'll give you guys a minute to copy that down. It is a common problem at this stage in the game, as we're getting comfortable with trig, as we step into triangles that aren't right triangles, using law of sines and cosines. It's a common problem to have 3 pieces of information given and 3 pieces of information unknown. Now, as a first thought, and this should always be your first thought in any solve the triangle problem. Anytime you see that phrase, solve the triangle, 3 pieces given, 3 pieces unknown, you should start by trying law of sines. Try it. See what happens. Sine 36 degrees over x equals sine y degrees over 10 equals sine m degrees over 7. Do you see the problem? Yeah, what is it? You give me that.
There's, in every equation, there's more than one thing you have to find. Like if we had sine 36 over x and sine y over 10, you can't find one of these.
So, if you make an equation from these 3 statements, you're either going to grab the first 2, the outer ones, or the last 2. You grab the first 2 variables, you're screwed. No chance to solve. You grab the last 2 variables, you're screwed. Grab the outer 2 variables, you're screwed. No matter how you do it, there's no way to solve. So, if law of sines does not work yet, at least, law of sines is now nuked. Your option is to go to, that's a bad joke right now, in light of what's going on in the career right now. So, if law of sines is, if law of sines is dysfunctional, then we're going to have to go to law of cosines to function. And to do that, notice that in the law of cosines form, there's an angle that's involved in the law of cosines. And notice how we know the value of the angle 36 degrees. So let's take advantage of that. So let's use as our cosine 36 degrees, which means the side opposite that angle, the x, is how we're going to start writing the expression. So x squared equals 7 squared plus 10 squared. It's basically the squares of the other 2 sides. At this point it looks like Pythagoras, but then you have to minus 2bc, that's 2 times 7 times 10 times cosine of the angle. That's taking the form of law of cosines with the star next to it, noticing that we have an angle, noticing that using that angle might be helpful, and then noticing that the expression is just a matter of punching the numbers into a calculator. Because what we did there, using the law of cosines formula, is we now have a formula for the x that we don't know. Because we go to the other side of the equation and say 7 squared is 49, 10 squared is 100, 2 times 7 is 14 times 10 is 140, cosine 36 is 0.809, and we get 149 minus, make sure you have that minus. Some people in the past have made issues, or found issues by forgetting the minus. I should say they made issues for themselves by forgetting the formula incorrectly. And you put the whole thing together, and you get 35.74 is x squared. Take the square root of both sides, and x is 5.98. Well, now that you know what x is, now that you have one piece of missing information, you can go to your law of sines, and where you saw x, you could see 5.98. And now you can take the first and the second, or the first and the third, and solve for the other missing piece. So law of cosines is only ever used when law of sines doesn't initially work. But once you use law of cosines once, fortunately, you never have to use it again. I say fortunate because it's a big, chunky formula. So, to solve for the other piece, we can say sine 36 over 5.98 equals sine y over 10. This is going to be a good time for me to remind you of one of the hitches of law of sines, something that you have to be cautious of. When we cross multiply, we get that. Sine 36 is 0.587, I multiply it by 10. I get 5.87, I divide by 5.98. Sine of y degrees equals 0.983. When we undo that by taking the inverse sign, this is something we always have to keep in mind. Remember, sine is positive in both the first quadrant and the second, so you look at the angle to tell whether the angle is obtuse or acute. Now, my drawing is a little bit sloppy, but let's take a look here. So when I take the inverse sine, I'm going to get y equal to 79.4 degrees, or you could have a 79.4 degree angle in this quadrant, or you could have a 79.4 degree angle in that quadrant, which the amount of rotation that would do that would be 180 minus 79.4 degrees, which would be a 100.6 degree angle. Now shoot, when I look in the book at the angle, and when I look at the angle I drew up there, to me it is not obvious whether it's acute or obtuse. So at this point, it's going to be one or the other. And we're going to have to see which one it is based on what we would get for m. So it's one or the other. I don't think it's obvious from this picture. Remember that first example we had? We had the one that was like super wide and the one that was super narrow, and it was obvious to see. In this case, I don't think it's obvious. So let's figure out what m would be in each case, and let's figure out which m works in the equation. So when we look at the m measures, if y is 79.4, the other angle is 36, subtract from 180. So y equals 79.4 means that m equals 64.6. How did I get that? I took 79.4 plus 36, subtract from 180. Does that make sense? Basically find the missing piece. Now, if y is 100.6, that means m is going to be, subtract from 180, 43.4. Now let's see which of those comes out whenever we look at it, because I suspect that only one of those is possible. Maybe they're both possible, and if so, we'll just have to deal with them. Now to see which is which, let's grab sine of m here. Sine 36 degrees over 5.98 equals sine m degrees over 7. Cross multiply. 7 times sine of 36 equals 5.98 times sine of m. do the division, that's 7 times sine of 36. That gives you 4.11449676. Divide by 5.98. I'm trying to make this as real of an experience as possible, because if you were on your calculator, you'd see the same thing. And you get sine of m equals 0.688. That means m is the inverse sine of 0.688. And that means m is 43.4. Aha. So now we know which one we're dealing with. We're not dealing with the 63.4, because if the sine gives you a 43.4 value, just to be clear, you could have a 43.4 value in that quadrant, or a 43.4 value in the second quadrant. All students take calculus, sine is still positive in the second quadrant, which means you could have an angle of 43.4 or 136.6. 136.6 gets quickly rejected for multiple reasons. One, it's not possible based on our previous analysis. Two, if we put the angle in the triangle, you would notice that there would have to be an angle bigger than it, because there's a side bigger than 7 opposite the y. And if m had a measure of 136, y could possibly have something bigger than 136. You'd blow 180 degrees out of the water. So those are going to be your two angle measures, and there is your side measure. I think this is a really good example to go through, because you have to always be cautious of the fact with law of sines, I'll put a star here too, that you're going to have two solutions in each of your two quadrants. You're going to have an acute solution and an obtuse solution. And depending on the picture, it may be obvious, and if the picture's not obvious, you're going to have to do more digging. I suppose on one hand, if we, rather than going for the biggest angle first, if we went for the medium-sized angle, that would have given us an easier analysis, because we would have settled on this guy quicker, and then we would have settled on that guy as a result. So maybe in your head, if you think, once you do law of cosines, rather than doing the biggest side and the biggest angle that could be obtuse, do the medium angle, that would be one that would be unable to be obtuse. Does that make sense, reasonably, in your head? Okay, let's do another example. How about, does the camera see more than the first word? Just the first word?
I think just the first word, but I can just move it to the second word.
Awesome, perfect. Thanks. So here's another triangle. X, Y, and Z. 5, 7, and 8. Solve the triangle. The phrase solve the triangle means find the other 3 missing pieces. You have 3 pieces, you're looking for 3 pieces. First step is always to try law of sines, because I'm telling you right now, while we're in the law of cosines section, and you would assume that every law of cosines example would involve law of cosines, when you're on the test, you're not going to know whether it's a law of sines problem or a law of cosines problem, and you're not going to want to use the law of cosines if you could have gotten away with law of sines. Okay, so we try law of sines first, because even if we use law of cosines, we're going to come back to law of sines eventually. So it's a good starting point to just write out law of sines. Sine x over 7 equals sine y over 8 equals sine z over 5. Take any 2 of those, you have 2 variables. Law of sines initially is not the outlet. And this is requiring you to step up to law of cosines. Unfortunately, there are no angles known either. So, which form you use is whichever form you use. It's not going to matter. You okay?
Yeah. She was like, oh, poo.
Yeah.
She's kind of fun.
Yeah, so we have, I guess, choice here in one sense. In another sense, you have choice. So maybe that's a depending on how you look at it. I'll write out the form that you would start with. you could go 8 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of opposite 8 is y. That would be the one form.